Okay, so my peace be upon you all, everybody, in the name of God, the most gracious and most merciful. So now we're going to do the inverse of a parabola. So for the parabola, let's say you have that graph, right? This is the original graph of, let's call it f of x is equal to ax squared. And they will always give it to you as simple as this. The inverse, and they say, give the formula of the inverse. All that you're going to do is that the original graph is y is equal to ax squared. Wherever you see, you just switch around the x and the y. So then you're going to get x is equal to ay squared. And now we're going to solve for y. So you divide by a, you're going to get rid of that a. So x over a is equal to y squared. You want to get rid of the y squared. So therefore, y is equal to plus minus the square root of x over a. Always remember, if you have x squared equal to 4 and you want to solve for x, if it is squared and you want to square root it, don't say x is the square root of 4 and x equal to 2. No. You must say x equal to the plus minus square root of 4, x equal to plus minus 2. Because 2 squared is equal to 4 and minus 2 squared is also equal to 4. Therefore, your answer is x equal to plus minus 2 in this example. But in this case, remember, it's the same case. If you have a squared and you want to get rid of the square, y is equal to plus minus square root of a over x. Please pay attention to that. And therefore, the inverse is going to be if the inverse of x is equal to plus minus the square root of x over a. Now let's go into the application purposes. So what we're going to do, the first scenario we're going to do is, let's say a is more than 0. So let's say a is more than 0. So if a is more than 0, we know that it's a happy graph. So this is our happy graph. Okay? Right though. So this is our happy graph. Now let's say what is the inverse of this graph if you draw it? Now, please pay careful attention to this because this do come up in the exams. So this graph is f of x, okay? And f of x is equal to ax squared. A is more than 0. It's a happy graph and it looks like this, okay? Now, the inverse of this graph is going to be inverted. So you're going to flip it like this across the line y equal to x, and the inverse graph is going to look like this. Okay, and that's the inverse of f of x. Now in the exams, what they can do is that they can restrict the domain of f of x. Be careful, guys, be careful. We have to learn, we have to understand the phenomenon of restricting the domain. So there's two ways in which we can restrict the domain. We can restrict the domain by saying that x has to always be less than or equal to 0. Now there's 0, right? And that's the x. If we say that x must always be less than or equal to 0, less than or equal to 0 is towards the left. So then we're only taking the left arm of the parabola. So if we restrict the domain by saying x is less than or equal to 0, we're only taking the left arm into account. Then we restrict the domain. And why do we restrict the domain? We restrict the domain, make a note of this. I'm not going to write it down, but make a note of it. We restrict the domain so that the inverse of a parabola can be a function. Remember, the original parabola is a function, but this brown parabola is not a function. And that you can find out in my other video, in the introduction video I made on inverses and functions. So we restrict the domain to ensure that the inverse is a function. So If we restrict the domain by saying that x must always be less than or equal to 0, we're going to take the left arm into account. Now learners get confused if I ask them, okay, we restrict the domain like that. So, and the equation of this graph, of this blue graph of f of x, it's f of x is equal to ax squared semicolon x is less than or equal to 0. So ax squared, it's a happy graph, but we're only taking the left arm into account because we're restricting the domain. Then what is the inverse of this graph? It's very difficult because the question is this the inverse or is this arm the inverse? Now, always remember how to look at it is that take this graph and you flip it around. So look at my index finger over here. I take this graph and I flip it. Do you see where that finger is? So this arm is the inverse of that arm. So therefore, this arm is the inverse of that arm. Right? Pay attention to that, please. So this is my inverse of that arm. Then if we restrict the domain of x is more than or equal to 0, meaning if we only take our right arm into account of f of x, and you want to draw the inverse is going to be the opposite of that, which is that. And that is basically how to draw or identify the inverse of that arm. Remember, in this case, our original graph is f of x is equal to ax is x squared and x is more than or equal to 0. We restricting the domain by saying that x must always be more than or to the right of 0, meaning that you must only take your right arm into account, and the inverse will be this over here for the right arm of the original parabola. So look at my middle finger, I reflected, there's my middle finger, that line or that arm of the inverse is my inverse of that arm of the original parabola. Make a very important note of this, please. We're gonna come back to this in our examination past papers. Okay? And then another thing to understand is that we're done now with a is more than 0. So we're going to use the same example, but just going to make a is less than 0, where f of x is equal to minus ax squared. And if a is less than 0, it's a sad graph. It's a sad parabola. So it's a sad parabola. Sorry for the fat parabola. But let's say that's our original graph. Now if we reflect that graph over the line y equal to x to get the inverse of that graph is going to look like that. Okay? So the inverse of that graph is going to look like that. So just see the inverse of the original graph, of that sad graph. So this is the graph, and we reflect it. Okay, we reflect it over the line y equal to x. Now, and we know how to get the equation of the inverse, which I explained here on top. Now, what if we restrict the domain? Restricting the domain. We restrict the domain so that the inverse of the graph can be a function. This brown is the inverse. This is a function because it passes the vertical line test. This brown graph, which is the inverse of the restricted parabola. I call it a restricted parabola because we restricted the domain. This inverse, the brown inverse, is a function because it passes the vertical line test. Now, if we restrict the domain on this graph, let's say we say x is less than or equal to 0. So don't forget the function. The function is f of x equal to negative ax squared, right? So if we restrict the domain and we say that x must always be to the left of 0, we're saying that x is less than or equal to 0. So a is always going to be less than 0. We're only taking this arm into account for f of x. So then how do we draw the inverse? So follow my fingers. This is the graph of the parabola. Look at my middle finger over here and we flip it around. There's my middle finger. So this arm over here is the inverse of this arm. Be careful. So this arm, and this is very important, learners get very mistaken over here. So this arm is the inverse of that parabola. Okay? Very important. Okay? Very important. And then if we have x is more than or equal to 0, meaning we restrict the domain by saying that the graph is always going to be to the right of 0. So then we're going to take that arm into account. So then we restrict the domain by saying that the parabola is only that arm. So the function of the graph is still f of x is equal to minus ax squared, but in this case we say that x must be more than or equal to 0, meaning that x must always be to the right of 0, which is this arm over here. So the inverse of that graph is, just look at my index finger over here. We reflect it. There's my index finger. So this graph is the inverse of that arm. So then the inverse of this arm will look like that. And that is the inverse of that parabola. Okay? And I think we're going to stop over here. That is just the basic understanding of the inverse of a parabola for today. Thank you everybody, and that's a wrap. Peace.